There are many aspects to manufacturing that have changed over the last several years, but let me pick four that kind of highlight where we're focused when we say smart manufacturing. The first is the idea that you have a strong and I would say fairly complete robotics infrastructure for how you build and manage your products, not only from a build aspect, but that robotics infrastructure leads to the second element, which is large amounts of data flowing up from that equipment, either representing the equipment or representing the product. The third element would be how we use the Internet of Things throughout the manufacturing process to relay even more data about our products as we build them. And then the last element would be just newer manufacturing technologies that allow us to be more precise and I would say faster in how we do things. The generation of this intelligence to make the decision or this inference that makes the decision is not pre-programmed rules. That's a big distinction for how many things are done today. Just think about all the sensors that are in a factory. If we collect data on every one of those sensors, it's a massive amount of data, and we're not the only company that's doing that. We're in the process right now of co-developing this tool that will allow us to do real-time machine learning at the edge in a data center in each one of our factories. And it has really three elements to the tool. The tool has an element that we call an inference engine. After you've trained the device, it's going to use that neural network that you've trained to make decisions in real time on your product continuously over and over and over again. The second element of the device is what we call a deep learning algorithm. That allows the algorithm to pull massive amounts of data out of the cloud that you've been storing and use that data to update the algorithm and change the algorithm. So it's deep learning for the algorithm itself so that it adapts. And then the third element of that is there does need to be storage on the device, and especially if the factories are generating massive amounts of data, you don't want to send it all up to the cloud. You want some local storage on the device, enough such that it can help these algorithms learn, help the inference engine run as a way to deliver a better cost structure than you would if you were just sending everything up to the cloud, and a better real-time solution. So it's inference, learning, and data storage. And I think smart manufacturing will allow us to do it in a faster, more cost-efficient way. Data and robotics coming together.